and we thank you for accepting our invitation. Some Sir has graduated from NIT Jalandhar in 2001. Some of the highlights about Sir's career is that he has worked in Wipro for almost 10 years as a project manager, and now he's working at Intel as a hardware system designs architect. He has more than 20 years of experience in hardware and hardware related fields. So over to you, sir.
Okay, thank you. Yeah, so I will share my screen. I have some files. I'll give my intro while I share the screen. Okay, and I'll stop my camera uh, for a while just to make sure the presentation is smooth. Okay,
Okay, sir.
you were able to see me though, right? Till now?
No, sir, your camera is not
Oh,
switched
I'm
on.
so
Yes, sir.
sorry. Okay, let me show my face.
Yes, sir. Now it's
Yeah, now it is. Now it
Okay,
is.
I'm sorry. I thought it was working till now. Okay. So yeah, there were some issues. I'm working from home. So after the COVID, we are into a permanent hybrid mode. Okay, which means that we need not go to office every day. So, and we have gotten used to working from home. So there are some bandwidth issues today. So yeah, I'll stop my camera and let me share my screen. Okay.
okay, sir.
Let me know when you can see it.
Yes, sir. It is visible.
Okay, so yeah, this is Smith. I am a system architect at Intel, and this is what I have just prepared so that you guys understand how the journey looks like for a hardware engineer. Again, this is all hardware focused, hardware centric. Okay, and we all understand that from electronic stream, again, you can definitely get into the software. That's what most of the folks will get into, right? But this is targeted to see if the folks who are interested to continue in the hardware stream, right? What is that they have, what opportunities they have, how their work profile would look like, and how their career growth path would look like. Okay, and feel free to interrupt me, although we can have a QA session at the end of this presentation. But if any questions you have in between, do feel free to pause. Okay. Okay, so I started my career in 2001 as hardware engineer with Wipro, and in 2006, I if you're not talking, you can be on mute. That will help. Okay, so 2006, I became the hardware lead. Again, during this, so Wipro, as you know, is a services company, which means that we work for various clients, and I was mainly working in the telecom domain, all the while in Wipro, basically developing the switches, routers, Ethernet boxes, all of that sort of stuff there. Okay. Moving on, after a few years, 2009, again, got promoted as a hardware architect, again, catering to various design aspects, system design level architecture. I'll talk about it. What do we do there? Then after a few years in 2013, I got a good opportunity at Intel, and I joined Intel as hardware design engineer. And continuing my journey there in 2015, I took up the role of hardware engineering manager. Stayed in that role for a while, and then I realized my main passion was more into technical, and I switched back to a individual contributor, basically IC, we call it in the industry, IC role, as system architect in 2019, and since then I'm just continuing in that path. Okay, so my main expertise is problem solving, debug, and system design. and my hobbies are traveling, sketching, writing, music. I play a lot of music. There's a book I had written on, especially on how the work is on a lighter note, about the the work balance that we should have at our work. So uh, do check that out. Any questions on this? Okay, if not, okay, this is one foil I have prepared just to give you a glimpse of what all job opportunities and roles that you can expect. Again, I'm reiterating, this is for the hardware centric, right? Again, there is no dearth of other roles. You can always look for many other opportunities within the software domain, instrumentation domain, many other, right? But I'm just talking particularly about the hardware. So VHDL, RTL coding, validation, that's something most of you might already be aware. That's the, I think the majority of the chunk of hardware roles get into that. VLSI designer, engineer, also part of that. But the next set of the roles, right? That is what comes under the sort of system design umbrella. Okay, so you could actually sort of you can start as a hardware design engineer, and then once you move on, you can get sort of a specialization. You can choose your domain further, just like within your engineering, right? You start with the first year being the general subjects, and then you get into the specialized topics. So same happens in the industry as well. So you can always start with a basic sort of overall hardware design engineer. Now, that does not mean that you cannot stay that way. You can continue throughout your profile. Uh, okay. Sort of you're requesting for control. Looks like that.
Uh, I think there has been a
So I can deny
solution.
that.
Yeah, sure.
Okay. Okay, so yeah, what I was saying was, as a hardware design engineer, you can continue your profile as I just showed in my example, right? But then, if you are interested in a particular sub domain within hardware, there are enough opportunities. Now, all of these roles, okay, these are available in Intel. So we at Intel have all of these engineering roles, and similarly, Wipro or other companies where system design is there, these roles would be applicable there as well. Okay, so enough opportunities are there, which is what I wanted to make sure you guys understand, that you can really look forward if you are particularly interested in a particular domain. Right now, at this stage, maybe some of you may not be even knowing what you want, but once you get into the industry, once you start working, you may be clear about your likings and dislikings. The reason I'm sharing is so that, again, you know at this stage itself that various opportunities are there. Okay, so PCB design engineer is all about, again, mostly CAD related, but this can be as sort of complex as it can get. We have some 32 layer, 64 layer boards. Okay, very complex design where we need to really put millions of components onto a board in a specified dimension, right? And I need to take care of many other requirements in terms of the signal integrity, all that stuff. So PCB design engineer takes care of that to make sure all of those requirements are met. Okay. Hardware system design, I'll cover that in a little bit more detail. PD engineer. So this is a specific subdomain. Basically, this person will be sort of defining the power delivery circuit or the specs. They'll be creating the power delivery circuitry for any given design. So if any particular design, again, it may be any end device, right? It could be a PC for silicon for our for Intel. Eventually, the silicon fits into your mobiles, your laptops, tabs, and all of that, right? But there is a power delivery component. All of those devices need the power delivery. Same applies for telecom or your embedded designs. The power delivery, buck boost regulators, LDOs, how much current is required, what is the power efficiency required, all of that is a detailed design that is required. And there is a specialized PD engineers, most of the companies, they will hire those. Okay. Similarly, there can be a SI engineer. So we have dedicated signal integrity engineers. Their full-time job is to basically ensure that the design, whatever we have, the signal integrity of that is good. Okay, so there are definite tools for that. They make use of that, and they give inputs based on their understanding and the outcome of the analysis that they do. They give input back to, say, the hardware design engineer or the PCB design engineer to change some aspects if required, to make sure the signal integrity of the design is taken care of. Okay, then you have RF engineer. Again, applicable wherever you have the RF subsection in that device, right? Again, if you see the PCs, for example, you have the Bluetooth, you have your in the tabs, you have the SIM, embedded SIM, right? You have the Wi-Fi by default. So all of those requires antenna, small antennas, and with more and more smaller, thin designs that we get in the PCs, right? The how the antenna is placed, what is the design of the antenna itself. You need a specialization there. So we have specialized RF engineers who cater to that. Again, many of them probably would have started as hardware engineer, but they probably would have gotten a specialization over the course of time in the industry to get into the domain expertise of this. Okay. Then we have EMI EMC engineer. Basically, again, some of this I'm not sure how much you have learned in your current curriculum. But every device, if you see again, if your laptop, for example, if you check on the back side, there'll be some stickers and the markers which will say it's a UL compliant, or some compliancy symbols would be there, right? So that compliance is nothing but any device basically has to ensure certain certification, that it should not radiate beyond a specified level, or it should not stop working if you put it in a condition where some other device is radiating something. Say, for example, you put your device near a microwave, right? Your PC should not stop working. So that's emissions and immunity. Immunity means your device should be designed such that it is immune, it is safe to work, its functionality should not be impacted if you bring it near another device which is radiating badly. Okay. Or conducted immunity means, suppose your device is connected to the power adapter, there is a lightning strike, that lightning strike happens through the power cord, for example, right? That should not impact your PC. Your PC should not get damaged. So that's the immunity. So there is a specific requirements that needs to be taken care in the design, and we have dedicated design engineers for that sometimes. Then hardware validation engineer, basically the whole validation, functional validation. Once you design the board, all of that needs to be functionally validated. Right. So again, in some cases, the same person, this hardware engineer, probably will be doing the validation also. But in much bigger projects, you have dedicated hardware validation engineers, which will just validate. So they get the design, they read the functional documents, and they try to make their own test cases, trying to find out as many possible issues in the design, right? Which, so that the design is in the end as robust as possible. Okay, hardware debug engineer. Again, this is more applicable in cases where after design is done, it goes into the field right? So in the field, there might be many issues which are reported by the customers. So you get those issues, and there needs to be specified set of folks who need to work on those, right, to find out what is the issue, what is the root cause of that. So their full-time job could be again just debugging. So if you are one of those who like problem solving or debugging, this would be the good profile for you. Firmware engineers, again, it's a mixed role. Basically, you need hardware knowledge and a little bit of your software knowledge, the physical layer, right, the first layer. So if you are interested in a little bit of both, this would be another good profile. Okay, I'll take a pause here. Any questions, or do you think this is useful information?
Yes, sir,
Yes,
it
sir.
is a very useful information, and honestly, most of us don't know that these are some of the roles which are
Okay,
there in
great.
hardware
I'm
industry.
happy that was my, because I didn't want to really do something of a technical topic. Okay, I wanted to make sure that you guys understand that, because I personally was always interested in hardware. Okay, so that's how when there was a choice of a computer stream in a much better college, right, versus electronics, I took electronics because I was clear that's what I wanted to continue. Okay. So again, I wanted to make sure that you guys understand that in the stream that you are currently doing, right? There are enough opportunities, just that you need to be aware of those. And obviously, the right clicks, the little luck factor, all those are needed. But many times the folks are not even aware that these are there, right? Because they do not know that such roles are there. They just try to get into whatever is available. Right. Okay, so yeah,
So,
again,
yeah,
feel free to reach out to me later on. Any particular topic you are more interested in. Suppose somebody is interested in RF, right? You would have that antenna subjects, right? Now, if again, personally, that was one difficult subject, right? Arun sir only used to take that for us. But if few of you are interested and you think, okay, you want to take that, do feel free to reach out to me. Okay, was there a question or a comment?
yeah, just wanted to understand, for like at what extent is the software and hardware knowledge needed in FW engineer role, which is firmware engineering.
Okay, firmware engineering I'm not covering today, but we can discuss later offline. Okay,
Okay,
Saurav
sure,
has my contact details. I can help you on that. But
sure, sir,
today, in
sure.
interest of time, I'll just stick to the agenda, a little bit deep diving on the hardware system design. Okay, and what is needed for that.
Okay, sure.
Okay, so what does a hardware design engineer do? So again, as I mentioned, the two scopes here. So one is a chip level design, right? Within the chip, some of these, whatever I just showed here, PCB design, right? A corresponding role in the chip design will be a layout design. That is a layout of the chip, VLSI layout, right? And then VLSI coding. So that's at a chip level. But the moments the chips are available, right, all those have to be put together to get a product, right? So that's basically the system design, and a key part for a hardware design engineer. Basically, they are responsible for developing the circuit boards, right, where they put all the components together. And it is not as simple as you just say that, okay, put them together, right? All these complexity in terms of how do you define the power, signal integrity, how do you route when you are making the PCB. It's not as simple as just connecting two components. Okay, at high speed you have crosstalks, you have signal integrity issues, basically, which will impact the functionality of the device. To take care of all of those vectors at the same time, making sure that whatever you put, there could be challenges from the mechanical perspective. Mechanical engineers, the product engineer, mechanical product engineer for you will say that, okay, hey, my product dimension is this much only, and at this place I need a mounting hole. Basically, I need a screw to be put, so you cannot put your component here. So given those challenges, how do you make sure you get your hardware fit into that with all the requirements? Right? So all of that is the responsibility of hardware engineers. And then obviously making prototypes, uh, validating that, testing that, all that is a job of the hardware design engineer. Okay, so this is an example of a system engineering team, right, where the hardware engineer will be working with all of these sub teams. Okay, so thermal design, for example, again, thermal and mechanical, generally you will have the same person who will be doing both, but in some cases you may have a separate thermal engineer, a separate mechanical engineer. Okay, uh, so mechanical engineer, basically, as I told, again, they'll be responsible for complete mechanical aspects of the design, how the mechanical, say for a laptop, how what material to be used, where the padding has to be there, where the mounting holes has to be there, right? The thermal engineer basically will take care of the thermal aspects, which is nothing but uh, every component, eventually electrical component, it dissipates heat. It takes energy to work, and while doing that, it dissipates the heat, right? So all of that heat put together has to be managed in a closed environment, right? So eventually all of our products, again, if you see your mobile is a closed device, right? All your components inside, they generate heat. So that heat has to be transferred out, that has to be managed, because if it is not managed, your temperature will increase so much that it will burn the components. Okay, so there is a full-fledged thermal design aspects that needs to be taken care of. So the hardware engineer has to work very closely with the thermal design engineer. So they will, suppose you do a placement in a particular way, you put the components, right? But the thermal engineer may come back and say that, okay, since you have put this together, at this particular point, there's a lot of heat generated and I'm not able to take this heat out. Okay, so I want you to place ABC component at some other place, which might be a challenge for you, because the moment you do that, you may have your other problems in terms of the longer that path from component A to component B might bring your signal integrity issue, right? Which is where this guy, signal integrity folks, will come back and say, hey, this is not possible, right? So that is the sort of a challenge which you'll be working around, where multiple stakeholders might give their requirements to you. And how do you make sure that you take care of all those requirements, and some of that may be conflicting? Okay, so that is the challenge, and that is where is a real engineering. The word engineering comes, right? It's not simply a simple job of just putting things together and just giving it out. So part of it is similar to R&D. Okay, any questions? But at a high level, are you getting the understanding of how this things works together?
Yes, sir.
Okay, good. So now I will jump to the skill set that is required for a hardware design engineer. Okay, so some basics, very, very clear that there's no second thought on that. Fundamental knowledge in electronics design, mastery of digital and analog circuitry, so that is required. But what you learn, again, I don't know, I've not checked the latest curriculum, how much level of the industrial topics get into your curriculum, but at least at our time, the basic understanding of the digital circuitry was there, right? But then in the industry, you that gets converted into a sort of an interface, right? So say, for example, when two components need to talk to each other, there are certain protocols that are defined by the industry, Okay, USB is one example. You guys use the USB in your laptops on this one, right? So USB is a protocol. It's a protocol, a standard protocol defined that when two devices are connected through USB, how they handshake, how they talk to each other. Okay, there is a physical requirement of that. There's an electrical requirement of that, right? How as digitally, you know, 0101, right? But how this 0101 is used in all of these various interfaces: SPI interface, I2C interface, UART interface, okay, PCIe, HDMI, basically that is your display port, LAN, okay, the usage of 01, the binaries, how the data is transferred is completely different in all of those. So that protocol understanding is what you should be aware of. And that is, I think, one key thing which at this stage, the more you try to understand, it will help you to be better prepared when you get into the industry instead of starting to learn at that point. Okay, the next one is the CAD software. Again, all of this designing, as I told, the layout or the schematics. So those are two key points. The schematics is nothing but the connection, right? Electrically, you need to define what needs to connect to where. The pin 5 of component A to be connected to pin 3 of component B. That is done through schematics. Okay. In the layout is nothing but in the PCB, the trace, the copper, how thick should be the copper, how far should be the component A from component B. That is the layout. Okay, so you understand the difference between schematics and layout. Schematics is nothing but, if I give an example here, look here, the first picture. This is an example of schematics, and there are tools for that. That is what we use in and out in the industry to create the schematics. So that is nothing but telling the electrical connectivity that uh, this pin to be connected where all to which all other chips. Okay, and the layout is this lower picture in the tool. This is how you will connect. Okay, the pin has to be connected to which other pin and how. So you see all this stuff. This is nothing but different layers of the PCB. Okay, and you see here the snake pattern in the yellow, right? So this is example of signal integrity or a timing requirement. So some of the signals will have a timing requirement, right? If A, B, C signals have to be having the same timing requirements, but in the layout, their positioning is different. So the moment you have different lengths of this trace, suppose one trace is 1 inch, but the other trace is 5 inches. Okay, which means that their timing will become different. So what you need to do is you need to make sure the length of A also needs to be increased to 5, because the length of the 5-inch may not be possible to reduce, but you need to increase then the 1 inch to 5 inch. So you, instead of a straight line, you will do this zigzag to increase the length. Okay, so this is example of the layout. And the right top is an example of the how the PCB after this designing this looks like. These are actual traces, this actual PCB picture. Okay, so I go back here. So these are the softwares. I think some free trial versions are available. So do try these out. Okay, this will give you a good experience of how things actually work in the industry. And as I'm telling you, this is something we do till today, because this is how the products are created through these tools. So the Allegro, Concept HDL, or CAD. Okay, these are the schematics tools. Schematic as in electrical connectivity. And the DX Designer pads, these are the layout tools. Okay, any questions on this? Were you aware of these tools? Anybody has already worked on this?
Mm. No, sir.
Okay, so then this will be useful information. Okay, after this session, you can search for these in the internet, all these, whatever I've given, right? You will get the required leads. And again, any clarity you want or any additional information, feel free to reach out. Okay, moving on. So experience working with simulation tools. So simulation, as I told, signal integrity. So how do you find that? So basically, while you are designing, right? Because you don't want to design it and later find that the product is not working. So there are certain tools that you will use to check that. Okay, so these are again in black, various tools: Cadence Security tool, Mentor Graphics, Hyperlinks. So those are the tools which I think again some trial versions could be there. You can check those out, but that will be used to understand the signal integrity. How when you start a signal from the transmitter, how it looks at the receiver. Okay, is there an overshoot, undershoot? Is the signal really going distorted when it is reaching? Okay, those sort of checks is what it will do. PI is power integrity. So power integrity means, say, suppose you need to give 5 amperes to a component A. Okay, but on the PCB, again, I show here, you see those thick traces here in this. So these thick traces are for the power. They are more current carrying. So more the copper, the more current carrying capacity it will have, right? But is this enough? How do you know this much thickness is enough, right? So those are the checks that power integrity tools will do. So they will tell you that if it is a 5 ampere, this thickness is not enough for you. Okay, so these are the examples. So you see here the red one means that this particular shape or this thickness or the dimension maybe is a risk area. Your current is not basically it is getting into a hotspot here. The if your so there is something called the trace resistance, right? Copper resistance, although it is ideally it should be zero, but that's not how it is, right? So there'll be some minimal resistance. So the moment your current increases, uh, I square R, right? So let little r also will overall give you a high number because it is a I square. So when the currents are high, that I square R becomes high, and that is what you need to take care of. So these tools will help you understand that. Signal integrity, again, I gave an example, right? So this is a snapshot. Electrical rule checking, as I told, for example, you need to do some length matching, right? For a differential pair, you need to make sure that the P and N of that is equal length. How do you check that? Or how do you ensure that a particular trace should be some minimal distance away from some other trace? Because otherwise there can be a cross coupling. Basically, the high speed signal on one trace can impact the other. It can induce wrong signaling into the other line, which will make the functionality issues to the system. So how do you take care of that? So those sort of checks is what these tools will help you do. Okay. Then debug tools, oscilloscopes. I assume all of you guys would have gone through this or at least used this in your labs. Logic analyzers, I do not know how much you have used, or protocol analyzers, but as I told, protocols, right? So I2C, all of these interfaces are nothing but eventually there is a protocol. So when suppose you design a product with a USB, right? And the USB is not working. So how do you debug? How do you find out what's the problem? So that's where you might need a protocol analyzer. It will help you to understand whether, say, whatever transition needs to happen, is it happening properly? Okay, those are various tools to help you to debug. Then some other general, more better mathematics definitely will help you in the circuitry and the processing, but again, that's more of a generic thing. HDL knowledge, again, this is not a must, right? At a system design, you don't really need that, but obviously a plus point there. Um, Software languages, integration processes, again, if you are doing something where there are FPGAs or CPLDs, programming devices, their additional knowledge of those would be helpful, but again, not a mandatory. Experience with prototyping, that is something I don't think you need to do right now. That is something you will get to know when you get into the industry. But again, yeah, if something in your final year, third year, fourth year, there is something you want to make some POCs on your own, you get some basic knowledge of prototyping, that will be really helpful and a plus before you enter the industry. Last but not the least, attention to details, strong analytical thinking, problem solving, right? As I told, there's various challenges. Thermal may say something, SI may say something. The antenna engineer, for example, may say something that, okay, you cannot keep the device, your device here because it will impact my antenna performance, right? So then that's a problem for you. How do you solve that problem? That's pretty much our day in, day out job that we do. Okay, I did not have a time check. Let me see. Okay, we are 6 minutes up, and this is pretty much what I had. We can have the any questions or anything that you want to know beyond this, or how do you find it? Is it useful?
Yes, sir, it is very useful.
Okay,
Sir, I
Sir,
had a
so
I
question
yes,
like,
yes, go ahead.
Gaurav, were you speaking something?
no, no, I can wait, used speak first.
Okay, sir, as you shared a lot of profiles with us, right? So are
Yes,
there any skills which are, particular for that profile? Because there were so many profiles and, there and electronics being so vast,
vast, yes.
do we need to, be somewhat centric towards some skills so that we can get
Yeah, so
hired for
that is
that profile?
something which if once you know at this stage itself, if you know that you are really interested in power, for example, right? Then with this information, the moment you search for power design engineer or power delivery engineer, even in the internet, right? You will get to know various job profile, skill set requirements will be there. But
Okay.
again, if even if you don't go into that deep, what this means is uh, at least you know that there are those job profiles available. All you need to do at this stage is try to make sure that your power circuitry knowledge is absolutely clear. You're on top of it, right? Power engineers, again, basically, as I told, your regulators, your different type of regulators, buck boost regulator, buck regulator, right? Efficiency, how the efficiency is calculated. How do you design circuits for high efficiencies? How do you design circuits such that it is not taking much space? As I told, again, you have more sleek products now, right? So in that, you cannot design something which is taking half of the product space because you have many other components that need to sit, right? So how do you design something which is taking very small space but giving the required amount of current or power to your circuit, right? Those are the sort of things that is what the power engineers do. But in terms of the for now, the skill set is nothing but complete detailed understanding of the power circuitry and the regulators. So if you search for the various power regulators and PWM controllers, all of those is what you would uh, want to learn.
Yes, sir.
Okay, there was another question.
So I want to ask one question that if a person want to get into Intel, Then what should be his career path? Means, does he have to pursue MTech to get into Intel?
Yes, for Intel, at least until now, MTech is the mandatory requirement for fresh recruit. Fresh recruit means with no industry experience. If you don't have industry experience and you want to join Intel directly, then you need to be a MTech at least. For BTechs, basically it is through those are only experienced folks. So even if you have say 1 year experience somewhere else and you're only a BTech, and Intel finds that your skill set is matching you are the right talent, they can take you. So for BTech, you need prior industry experience to enter Intel. Without industry experience, MTech is must.
But sir, MTech people also means they leave the college in after doing BTech, and after only 1 year they get hired in Intel. But in the first year of
Yes.
Intel, they are only first year of the MTech, they are only taught the BTech subjects only. So why this difference?
Oh, that's not something I can answer. That's the HR that has come up with those requirements, right?
But sir,
There could
there
be
should be consider.
various reasons for that. Okay, I mean, what I'm saying is I am not in that role to comment on that or even change any of that. That does not come from us.
Okay, sir.
That
Okay, sir.
requirement definition.
Yeah. So
Good afternoon.
one more thing was that for like what kind of circuits are mainly handled by Intel? Like is it more digital or like analog or like is it both? Means which
Both.
is AMS.
Yeah,
Okay.
so more digital. Again, when you say analog, so uh, from our scope perspective, at least the one that I am doing, like, so I'm currently into the PC, your laptop design, right? So there, the power is obviously analog, right? But and then audio, some of that audio section is analog, but rest of it is more digital.
Good afternoon, sir. Is my voice audible?
Yes, it's little uh, feeble, but I can hear you.
Sir, I'm an MTech VLSI design student, first year.
Okay, I can stop
And
sharing. I'll turn on my camera. Yeah, go ahead.
in second year, we will have to go for internship. Before
Yes.
internship, sir, I want to. There are actually two domains: digital domain and analog domain. So, how one can decide whether which domain to go, or could you please give some information related to both so that base on the basis of those information one can decide that in which domain they should go, like uh, uh, like whatever
No, my answer to that
the
would be you should be knowing what you want. When especially in the MTech, which means you are beyond BTech, you are doing an advanced course, right? At that stage, you should be knowing what your likings are. So again, I am my way of looking is think from your likings perspective. Don't think that the digital market is more. That is why I should do digital. Again, some of you may take that way because the job opportunities are more here. So I should do that. My take is always do what you like. If you like analog, okay, you will find a way or you will find the right job profiles eventually. And that would be the better thing for you to do. Instead of because
okay, sir.
once you take up something which if you do not like, right, it is not a one time, it's not a 4 year course or 2 year course. It's a lifelong journey where just like you have exams in the industry, there is appraisal, right? End of the year, you have salary hike or there are those uh, appraisal means basically they'll check how you performed, right? Your performance checks. So they suppose they need to cut down on some people out of 10, they need to remove. So those are also there, right? It's not a government job that it'll stay forever. So if you are into a job which you like, you are more likely to perform better. instead of taking something just because you thought is more opportunity and you took it, right? And then 5 years, 10 years, you are continuing, but since you did not like it, maybe you are not best at it, which eventually could affect you sometime.
Okay, sir.
I hope
And
you're
one more
getting the
thing.
point, right? So go by your what you like. If you are not clear or there is nothing preferred liking, you are okay for both. Then yes, then whatever you feel appropriate. If you think that digital is more vaster, then go with that.
Sir, is there any advantage or disadvantage in both of them? Like money is more in this, or scope is more in this domain, or like that?
No, I don't think that is the discussion point. Money and all those things keep changing. Okay. So suddenly after the COVID, the health sector is the number one, right? So money is
Okay,
best
sir.
in health sector. So that way we should all change to biotechnology suddenly. So don't always go with that. Again, my take is if you are very good at something, even if opportunities are less, right? But if you are good in it, you get into a good job, right? You can grow faster and you can get the same money through what you wanted also, which you were looking for from other means.
Okay, sir. And sir, in second year, we will have to go for internship, and prior to that, we have to clear the interviews or of various companies like Intel, Cadence, etc. So,
Yes.
could you please tell all things one should prepare to make 100% chance to get selected in the internship or interview, and then as a full-time job?
Yeah, I think what I shared as those profile requirements, right? And with this knowledge that you know that these are the sort of roles. If you did not know of those, you won't be preparing accordingly, right? So now you search, give little more search of those profiles, right? And the particularly for the hardware system design, all those protocols, all those uh, tools that I shared. If while in the interview, if you say that, okay, this is what I went through, I designed some circuit using ORCAD, okay, and I did simulation through hyperlinks. The moment you use these words, that's what they'll be very happy to hear those.
Okay, thank you so much, sir, for replying all my doubts.
Okay, welcome.
Just one of the last queries we had that like how can some intern, uh, get his FT conversion during his internship? Like, are there any advice for that? Because like right now we do have 6 months internship in our curriculum, which is there in the 8th semester. So
Mhm.
like some companies give it on the basis of the performance, and mostly the hardware companies only hire interns, and after that they give FTE offers. So this is what we are really struggling with, that how to actually get an FTE offer after
Yeah,
getting the
again,
internship.
that there's no one answer, right? That is very subjective.
Okay.
Many companies, again, there might be some numbers that they get n number of interns, right? But their conversion requirement could be just few. So suppose they get 10 interns and their requirement to convert into full time could be just two, right? Which means that the ratio will be very less, right? And in some companies, they may not even have any plans to convert. So it's just an internship. So it depends. It's a very subjective. There is no one answer to that, right? Again, the simple answer to that would be if as much as you can show your knowledge base in those 6 months or 1 year, in MTech it is 1 year generally, right? And the prior knowledge that you have and you can put it to action in the time that you are there, that's all you can do from your side. Okay, so focus on what you can do on your side, not what the company will do. Always.
Yes,
Okay, and
that's
stay
more.
same applies when you are in job also.
Yes.
Instead of more focusing on what others he or she is doing. Okay, he's at this level now, he's earning this much now. Instead of that, don't keep jumping. Like I see that trend, after 1 year you will jump because another company is giving double salary, right? What you will realize is after 10 years you are at a very good salary scale, but maybe you have not gained enough knowledge, and that will bite you after 15 years. So eventually everything will balance out. Okay, so in your beginning years, focus on more work, how much work you can get, how much you can learn.
Yes, I think that's more insightful.
Okay, good to know that. Okay, I think we are 20 minutes up. Yeah. Anything else, guys?
Sir, any college memories you would like to share with us?
College memories. Yeah, it's been long. In fact, every time I visit, so I am from Ludhiana, uh, but somehow I didn't get a chance to visit the college, but definitely I'll plan. Yeah, good memories. I used to stay in the hostel, although it was not far from my place. So weekends I used to visit my home. Uh, but yeah, Arun sir was again, Mamta ma'am, they were our favorites, as for most of the other folks. So I think my latest interactions with him, that is where we are, why we are here talking, right? But it was good. I remember our building especially was the best, right? The central building, the canteen. But it'll be good to see how it looks now. And yeah, I think Vidipur, you guys go there?
Yes, sir. And we have currently moved out to a new building of the department.
Oh, it's no longer in that central admin
Yeah,
building.
yeah, that
Okay,
has been
okay.
converted to administrative block.
Oh, that's a completely administrative block now. Okay,
Yeah, we've got a new
okay,
building now.
okay, okay. Good
Yeah.
to know that. Okay, yeah. Okay, that's all, guys. Nothing else. Let's wrap up. And again, as I mentioned, any particular sort of a detailed information that you need, again, I cannot commit that I can help with everything, because I may also have some limited knowledge in some areas, right? But I can try to help you guys as much as possible. Okay.
Yes, sir.
Okay, with that, wishing you all the very best, and looking forward to seeing some of you in Bangalore. So I work out of Bangalore, yeah,
Sure,
and
sir.
yeah, I
Awesome.
think a
See you soon,
good
sir.
number of guys will end up here. So we'll catch up with you.
Sure, sir. Thank you, sir, for
Okay,
your time.
yeah, thank you
Okay.
so much. It was my pleasure talking to you guys, and looking forward to meeting you again. Okay, bye.
Yes, sir. Thank you, sir.
Bye, sir.
Thank
Thank
you.
you so
Bye bye.
much.
Bye.
Gaurang, take attendance 2 or 3 times.
I have taken in between the meeting.
Okay.
Still, like, do we need to send our roll numbers or like in
No, you
chat?
must have got the email IDs in that. So if we'll just get it, cross-checked with their official mail IDs.
And some of people have contacted me, like they weren't able to join. One of them had an interview at 2, and 2 were like traveling. So I will send those 2.
Okay, no issues. We can look at that. Okay, thank you everyone for joining. We wish to have more such interactions in future. Thanks. Thanks for joining.
Saurav, I wasn't able to join earlier. Can you just look if my attendance is done? I joined around 15 minutes late.
I think Gaurang will compile attendance for today. So in case you weren't, you can, no issues. We'll get it marked present.
Thank you.
Actually,
Thank you.
sort
No
of
worries.
no mail IDs there has been is in the Excel sheet. There are like names and even the people who hasn't joined with their official ID. Only guest has been written on their like name.
Okay, so what you all are required to do is you need to type your roll numbers in the chat box right now. All of you type your roll numbers in the chat box. Maybe that we can use as well.
It is not open to everybody. Chat in channel meetings is only available to team members.
The chat is restricted. You need to allow the permissions to write the roll
Uh,
number in the chat.
Sir, I'm
Okay, no
allowing.
issues. I think everyone is present. Gaurang, 100% attendance is there.
Yeah.
Yeah,
Thank you so.
almost everybody was present, so
Yeah,
now
yeah,
people have left.
yeah. Okay. Thank you so much.
Everybody can leave now.
Yeah. Happy Diwali and thank you so much for coming.
क्या दे happy वाली